Bonsai is a Japanese word that means plant in a pot. Growing trees in pots is a revered art that actually began in China more than 2,000 years ago. During the past century, creating artificial trees known as bonsai zoke has evolved into a hobby with global appeal. Whether it's rustic pine, flowering cherry, or Chinese elm, bonsai zoke can be made to resemble a variety of trees. Some include stones and small statues, a Chinese tradition known as penjing. A craftsman starts by wrapping 13 strands of wire with stretchy, sticky tape used by florists. He uses 13, partly out of respect for a traditional Asian preference for odd numbers. Later, these wires will form parts of the trunk and branches. He wraps the wires with strips of paper towel for thickness and flexibility. To hold the paper towel in place, he wraps the ends of the wires with more floral tape. He then separates clumps of plastic pine needles from their branches. Ironically, this fake vegetation is imported from China. Next, he snips off the ends of the branches, creating segments about 2.5 centimeters long. To reinforce and support these segments, he wraps them with tiny wire that's 0.5 millimeter in diameter. Next, he wraps the segments with floral tape to give them a more natural, branch-like appearance. Then he inserts these segments into the pine needle clumps. The thicker end becomes the bud and holds the clump on the segment. The craftsman now places 3 of these leafy segments together and attaches them with wire. He bends them sideways in the same direction. This mimics the tendency of natural branches to lean towards the sun. For more mature-looking buds, he uses different 3-headed artificial segments. For integrity, 2 different types of buds are never used on the same tree. To add character, the craftsman uses a piece of weathered driftwood as the base of the trunk. He anchors the long wrapped wires into styrofoam around the bottom of the base. He staples the wires to the driftwood and wraps floral tape around the wires surrounding the base. Then he twists the wire to form a sinuous shape, what the Japanese call moyogi. He covers the trunk with soft gray modeling clay, adhering closely to the shape of the driftwood underneath. This will later be covered by artificial bark and moss. This process can take several hours, just part of the 4 to 6 days it takes one worker to make a bonsai zoke. The craftsman then applies slow-drying glue to one side of strips of rice paper. The strips are 5 centimeters long and 2.5 centimeters wide. He uses about 50 to cover the trunk, like bark on a tree. He dabs them with a wet rag so that the creases will remain when the glue dries. The creases make the bark look realistically aged, one of the hallmarks of a good bonsai zoke. Craftsmen are careful to place the branches in the traditional triangle shape. The lower branches must droop, as if weighed down by the elements. They add the leafy segments to the ends of the wire branches, attaching them with wire and floral tape. Using a knife, the craftsman trims away the excess styrofoam around the tree trunk. He then places the tree into an argyle pot that's 22 centimeters in diameter and 5 centimeters high. Using a sculpting tool, he covers the styrofoam in the pot with brown modeling clay. Using slow-drying glue, he covers the clay in several shades of fake moss. They range in color from dark brown to light green. He doesn't let the glue dry between each layer because the blending of moss and glue ensures a more natural-looking ground cover. He gently blows on the moss to scatter it across the base. He also applies glue further up the trunk, adhering moss that's thicker and lighter in color to resemble lichen. The finished bonsai zoke is 45 centimeters high. It needs none of the constant care required by its natural twin. Depending on their size and complexity, artificial bonsais range in price from $50 to $800. The adage, "It's hard to improve on a good thing," certainly applies to the trombone. The modern trombone isn't really much different from its medieval predecessor, known as the sackbut, with its distinctive S-shape, hand slide, and bell section. It's a blast from the past, and a pretty loud one, but it can also sound smooth and mellow. The trombone literally slides down to the low notes. It's the only instrument with a hand slide to lengthen it in order to change pitch. To make a trombone, they cut sheet brass in the pattern of a bell stem. They shape it by wrapping it around a steel rod. Using a nylon-headed mallet, the worker hammers the brass to shape it further. It takes just a few minutes for him to hammer out a rough bell stem form. He spreads open the stems slightly so he can make small notches on one edge with snippers. Then, with a brass-headed hammer, he taps down the notches so they hold the edges together. With an acetylene torch, he joins the notched seam, melting in a brass alloy wire to bond it securely. But the seam overlaps and it's too thick, so he runs it through a seam roller. 2 tons of pressure thins it. But now the bell stem is too flat. To round it out, he shoves it onto a bell-shaped rod and hammers it back into shape. Then he irons out the hammer marks with rollers. The bell stem, fitting loosely on a steel mandrel, goes through a draw bench. A hydraulic cylinder pushes it through a thick lead washer, pressing it tightly around the mandrel to its shape. To make the bell flare to attach to the stem, he puts a brass disc on a spinning lathe. Using pliers, he turns the edges of the disc to prevent it from flapping while spinning. With a lever, he manipulates a scissors spinning tool, pressing it against the turning brass disc. This shapes the disc into a flare. Making a trombone flare is a delicate business and is the work of a skilled craftsman. Getting it right is critical because the shape will affect the tone of the trombone. Next, with a torch, he braises the flare to the bell stem. The bell stem and flare now turn on a mandrel, while he presses against the seam with a wooden tool. This flattens the seam and gives the bell its final shape. Now it's time to make the tubing. A hydraulic cylinder pulls it on a mandrel through a die, stretching it considerably. In this way, both the diameter and thickness of the tubing are precisely controlled. Then, they become ice tubes, after they're filled with water and put in the freezer. The ice will keep the thin tubing from buckling in the next process. With a lever, he bends the tube around a U-shaped block. As he works it into a U-shape, the tubing hardens. After the ice melts, he places the U-bend in a balling-out die. He lubricates the tubing with oil and places a steel ball at the top of the tube and presses it down. He drops in smaller balls, and they push the first larger ball through the U-tube. This stretches the inside of the tube, rounding it to the correct diameter, and then the balls exit at the other end. Now he pieces the tubes together and solders them the same way a plumber joins copper tubing. He adds a loop for the valve section. In total, a bass trombone has 2 3/4 meters of tubing. Straightened, that's enough to reach from the floor to the ceiling. But of course, trombone makers are more interested in musical highs and lows. Finally, he solders a brace into place to add structural strength to one of the loops. A diamond-tipped tool engraves the company logo onto the trombone's bell stem, and a cloth buffing wheel spins against the trombone flare to polish it. This custom trombone has been built in approximately 50 hours, something worth blowing a horn about.